Okay, so today we're going to start chapter 3, and I think you'll think this lesson today is super easy. Hopefully today and tomorrow will be a little easy for you. In the next 2 days, basically kind of go back to Algebra 1, where we talked about slope, and we talked about equations of lines, and slope-intercept form, and point-slope form. So that should all be reviewed. Even today and tomorrow should be a little bit of review from pre-algebra. And then we have 1 or 2 other lessons that are a little more geometrical that maybe you haven't done before. But overall, you should do better on this. Chapter should be, your friend. It should be, because you've done it before. It should be a lot of review. All right, so today we're talking about parallel lines and transversals. And parallel lines are coplanar lines that do not intersect. Okay, kind of like the opposite sides of a railroad track. They don't intersect each other. They're parallel lines. This is how you state that 2 lines are parallel. Okay, PQ is parallel to RS. These can be lines, they can be segments, and you put a little parallel symbol in between. That's how you state that 2 lines are parallel. If you notice on these lines, I've got these little arrows. Okay, what they do is they show that the lines are parallel. Okay, notice there's a single arrow on each one of them that indicates that those 2 lines are parallel to each other. Now, let's say that we had a figure, a parallelogram. It's not this picture, but anyway, it's a parallelogram. And by definition, a parallelogram, opposite sides are parallel. Okay, so you would have these pair of sides are parallel, and then for the other 2, you would have arrows, but they would be double arrows. So that means that these are parallel to each other, and those are parallel to each other. We also have parallel planes. Parallel planes are planes that do not intersect, like the ceiling and the floor. Or if you have this Kleenex box, the top and the bottom of a Kleenex box, or the sides of the Kleenex box. Those are parallel planes. Then we have skew lines. Okay, and skew lines are lines that do not intersect and they are not coplanar. This line AF and line BC are considered skew because even if they were extended, they would never intersect, but you can see that they're not in the same plane. Okay, if I looked at this Kleenex box, this edge here and this edge here, if I extended those, they would never intersect each other with it. Okay, so those, but they're not in the same plane. Those are considered skew. Okay, so let's answer a couple of questions. It says name all planes that are parallel to planes ABG. Okay, this right here is plane ABG. Okay, and name a plane that is parallel to ABG. DCH, okay? So DCH. You can name it DCE as well, okay? So this one right here is parallel to the one on the top. Remember, when you name a plane, you use 3 non-collinear points. All right. So let's look at the next one. Name all segments that intersect CH. Okay, here is CH, and I want all the segments that intersect that segment. What'd you say? CD is one. Okay, what else? EC is another. BC. GH. There should be one more. EH. I did HE, same thing. Okay, so those 5 segments intersect CH. All right, next one, it says name all segments that are parallel to EF. Okay, parallel. Okay, so what do you think would be parallel to EF? AD, okay, AD, what else? HG, and there's one more. CB, okay, wait, EF, CB, yes, sorry, got distracted. Okay, so CB. Now, these look a little bit weird, this one right here and this one right here, but they are considered parallel to each other. There's a plane that could go diagonally through the middle of that prism, okay? All right. Name all segments that are skewed to BG. Okay, name all segments that are skewed to BG. So what would be skewed to BG? Okay, EF would be one. Okay, AD would be another. All right. EH, okay, good. There's two more. What'd you say? DC? Okay, DC would be one. And what? HC would be parallel. DE would be parallel as well. What'd you say? EC? EC? Is that what you said? Yeah, EC would be good. Over here. All right. So all 5 of those would be skewed to BG. Any questions on that? Okay. Now, here's a new term, or you might not be a new term, but one you may have forgotten about it. It's a transversal. And a transversal is a line that intersects 2 or more lines in a plane at different points. A line that intersects 2 or more lines in a plane at different points. This line T here is a transversal. And it intersects M and N at 2 different points. Okay, so it's a line that intersects 2 other lines at 2 different points. So my line T here is my transversal. Now, when you have a transversal that intersects 2 other lines, you get some special angles that are created. Okay, and so we're going to identify what these special angles are. Tomorrow, we're going to talk about what happens when your transversal intersects parallel lines, because then these special angles take on special relationships. Okay, all right. So the first thing we want to talk about are interior and exterior angles, okay? Now, your interior angles are going to be inside the 2 lines that are intersected by the transversal. So everything inside here would be interior. And then your exterior angles is what's going to be outside of the 2 lines, okay? So what would my interior angles be? Okay, angle 3, angle 4, angle 5, and angle 6. Okay, and what about my exterior angles? 1, 2, 7, and 8. Okay, angle 1, angle 2, angle 7, and angle 8. So those are my interior and my exterior. All right, now I have some special type of exterior angles. Okay, I've got consecutive interior and I've got alternate interior. Okay. And they're, to me, exactly what they sound like. It says consecutive interior. Consecutive is in a row, okay? And so it would be interior angles that are on the same side of the transversal, okay? So they're in a row with each other. The same way with the other side, okay? So one pair of consecutive interior angles would be angle 3 and angle 6. And then what would the other pair be? 4 and 5. Kind of crossed them out, didn't I? Angle 4 and angle 5. Those are consecutive interior. Then the next ones are alternate interior. Okay? They alternate with each other. So they're on opposite sides of the transversal, diagonal with each other. So that would be like angle 3 and angle 5 would be one pair. And then my other pair would be angle 4 and angle 6. So those are alternate interior. Then we have alternate exterior angle, which is the exact same thing as alternate interior, except they're in the exterior. All right, so what would that be? Angle 7 and angle 1 would be one pair. And angle 2 and angle 8 would be the other pair. Okay, so those are alternate exterior angles. Okay, and then lastly, we have our corresponding angles. Now, corresponding angles, for whatever reason, tend to be the ones that are hardest for people to see. But they correspond. They're in the same location in regard to the lines and the parallel line. For example, 1 and 5 is one pair. Okay, that's corresponding. They're both on the left side of the transversal above the line. Okay, so to the left and above. So that would be angle 1 and angle 5. Okay, give me another pair. 2 and 6 would be another pair. Okay, so angle 2 and angle 6. Okay, another pair. Okay, 4 and 8. Those are both to the left and below the line. So angle 4 and angle 8. And then the last one, 3 and 7. Okay, angle 3 and angle 7. All right, so those are my special angle pairs. Okay, now let's take a little different slant or a different way of looking at it. We want to next identify the transversal connecting each pair of angles, then classify the relationship between each pair of angles. Now, one correction I want you to make is on letter C, change this to 2 and 9. I think yours says 2 and 6. Make it 2 and 9. Now, not really hard, except for sometimes when you have all these numbers, all these angles, all these lines, things kind of get jumbled. So what I recommend doing is highlight the lines that create the angles. And that'll help you be able to determine the transversal and the relationship between the angles. So if I'm talking about angle 1 and angle 9, for angle 1, I need this line. For angle, I need this line here also for 1. And then for 9, I need this line right here. So if I have those 3 lines, I can create angle 1 and angle 9. So what would my transversal be? Remember, the transversal intersects 2 other lines in 2 different points. L would be my transversal, and then what kind of angle pair would 1 and 9 be? Alternate interior. That is correct. Good. All right, let's look at the next one. All right, angle 5 and angle 6. So here's 5 and 6. I need this line, I need this line, and I need that line. Okay, so what would my transversal be? Okay, good. And so then what kind of angles would 5 and 6 be? Corresponding. They're both to the right of the transversal above the line, right? So that would be corresponding angles. Okay, next one is 2 and 9. So I need this line here, I need this line here, and I need that line there. What's my transversal going to be? L, and so what kind of angles are 2 and 9? Consecutive interior. And I'm fine with you guys using abbreviations, that's fine. Consecutive interior. Okay, 3 and 12. Okay, angle 3, you need this line, you need this line, and then for 12, you need that line. What's my transversal? H is my transversal, okay, and what kind of angles are those? Alternate exterior angles, good. You see that? Alternate exterior angle. They're outside of the transversal on opposite sides. I mean, outside of the lines on the opposite side of the transversal. All right. Last one is 5 and 10. So we need this line here, we need this one, and we need that one. What's my transversal? K is my transversal, and what angles are those? Those are corresponding. Even though there's another line in between them, they're still considered corresponding. To the right of the transversal, above the line. Now, one of them that I don't have up there, I want you to, it's kind of a weird question because it's not really in relation to all these angles that we just learned. But what if I asked you about what would I call 11 and 12? Angle 11 and 12. There's not a transversal that creates those, is there? There's really just 2 lines, isn't it? What do we call those kind of angles? They are adjacent, but more specifically, they are supplementary, but why? What are they called? They're supplementary is their relationship. They're a linear pair. Their name would be a linear pair. Okay? So, this right here, those would be a linear pair. All right. Any questions?